Okay, so in this video we're going to be introduced to what's called factorial notation. We'll encounter it by looking at one or two examples. So, for example, in how many ways can I arrange 7 books on a shelf? Well, I've got a choice of 7 books for the first place. Then, having chosen one of those, I now have a choice of 6 for the next place, then 5, then 4, then a choice of 3, then a choice of 2, and then basically no choice for the last book. I've got to take that book. Now this idea of multiplying a number by all the numbers less than itself down to 1 occurs often in counting techniques, and so we've got a symbol for it, and it's 7. We don't say 7, but it's called 7 factorial. So if we just take a look, there's a factorial button on our calculator to save us some time. So 7 shift there, 7 factorial equals, and the answer in this case is 5,040. So there are 5,040 ways that you can arrange 7 books on a shelf in a row. Let's look at another example. In how many ways can 13 people stand in a line? Well, it'll be 13 times 12 times 11. It'll simply be 13 factorial. Let's take a look at that number. 13, shift factorial, and rather a large number. Let's look at a slight variation of this problem. In how many ways can 13 people stand in a line if the 4 women must stand next to one another? So now there's a little kind of cognitive trick here, but if we were to put a band around these 4 women, and treat them as a person, then basically we would have 1 person, 2 people, 3, which is our group of women, 4, 5, 6, 7, 8, 9, 10. And the way we can arrange 10 people in a row would be 10 factorial. However, those 4 women themselves, for any arrangement, so for example, let's say I've got some men and then my group of women all together with a kind of band around them. So I've got 1, 2, 3, 4 men, my woman, and then another 5 men. But for any arrangement, these women inside the band could themselves arrange in 4 factorial different ways. So in fact, the answer would be 10 factorial times 4 factorial. That's the number of ways that they could stand if they were going to be, if the women were going to stand next to one another. Let's look at another example. Now I've still got 13 people, but if the men must be together and so must the women. Well, now what I've got, I'm going to put a band around the 9 men. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put a band around the 4 women. Right. Basically, if I think of this as a person and this is a person, they're 2 people. 2 people can be arranged in 2 factorial ways, which is just 2. I can either have the men on the left and then the women on the right, or the other way around. However, for every single one of those arrangements, these 9 men can actually stand in 9 factorial different orders. And for every single arrangement, these 4 women can stand in 4 factorial different orders. So that little cognitive trick of putting a kind of rubber band around them gives us our ability to calculate the final answer.